Good morning, students, and welcome back to our online classes. We are doing chapter number 7, Study of Gas Laws. So let us do our quick revision of what we have learned until now. Study of gas laws. Here we have to study about 3 gas laws, and they are Boyle's law, which we have already completed, Charles' law, which we are doing and we are about to complete, and finally, when the conditions of Boyle's law and Charles' law are combined together, then we get an equation called gas equation, which is the combination of Boyle's law and Charles' law, which we have to do later. So in our today's class, we are going to do a quick revision of Boyle's law and Charles' law, and there are 3 numericals based on these 2 laws which we have to solve as your today's assignment. Now, I would like to give you a review of reduced syllabus for this chapter, and this is according to the board, ICSE board. So the study of gases, what you have to prepare yourself for this year. The behavior of gases under changes of temperature and pressure, explanation in terms of molecular motions, which we have done, Boyle's law and Charles' law, absolute zero, gas equation, which we have to do now, and simple relevant calculations, which we are already doing. The behavior of gases under changes of temperature and pressure, explanation in terms of molecular motion. More the motion of the particles, more will be the volume. If the temperature is increased, the motion of the particle also increases, and hence there is an increase in volume. So this thing we have learned in the beginning of this chapter. Now in Boyle's law, you have to learn the statement of the law, its mathematical form, and simple calculations, which we have already covered. In Charles' law, you have to again learn the statement of Charles' law, its mathematical form, and simple calculations, which we have done, and we are going to revise it today also. And you have to make yourself clear about absolute zero, which is Kelvin scale of temperature. Okay, and finally you have to learn about gas equation, which is the combination of Boyle's law and Charles' law, which we are going to do. So without doing any delay, let us quickly revise 2 gas laws, and they are Boyle's law and Charles' law. Now let us first revise Boyle's law. Boyle's law states that the volume of a given mass of dry gas is inversely proportional to its pressure if the temperature remains constant. Here, Boyle's law talks about a relation of volume of a given mass of gas to its pressure when the temperature remains constant. So when the pressure is increased, inversely means volume will decrease. Inversely means oppositely related. If one increases, the other decreases. Okay, so if the pressure is now decreased, volume increases, and if the pressure is increased, volume decreases. And its mathematical form is P1 V1, that is pressure, initial pressure into product of initial pressure into initial volume, is equal to product of final pressure and final volume, and their product will always remain same, and that is why it is a constant. The product of pressure and volume is always constant. So this is the mathematical relation of Boyle's law, or mathematical representation of Boyle's law. Okay, boys. Now when the pressure is increased, the particles come closer to each other, and therefore their intermolecular space decreases, and hence the volume also decreases. And when the pressure is reduced or decreased, the particles get more space, they get freedom to move from one place to another place due to the increase in intermolecular spaces, as a result of which volume decreases, and that is what is explained by Boyle's law. Now let's move on to another law, Charles' law. It states that volume of a given mass of dry gas is directly proportional to its absolute temperature. Here we have, what type of relation do we have? directly proportional. That means if one increases, the other also increases. If one decreases, the other also decreases. But the condition is here the pressure remains constant. So here, in terms of molecular motion, let us try to understand. So when the temperature of a given mass is increased, what happens is the kinetic energy of the particles increases, due to which now the particle will start vibrating very rapidly. And more the vibration, more area it will cover, more towards larger space the molecules or the particles can move, due to which the volume also increases. Now, if the temperature is decreased, the kinetic energy of the particles also decreases, due to which their motion also gets restricted. Hence, the volume also decreases. Okay, so this is the direct relation which is explained by Charles' law. Here, the relation of volume with absolute temperature is explained when the pressure remains constant. Now, in our next class, we will start our final law. It is not actually law, it is an equation which is a combination of Boyle's law and Charles' law. That we will do in our next class. So, this much for today's revision. Now, based on today's revision and our earlier class, so this is the mathematical representation of Charles' law. Now, here is your assignment number 4. Solve the following numericals. Question number 1, convert the following: minus 273 degrees Celsius to Kelvin, and B, 173 Kelvin to degrees Celsius. So you have to convert these two temperatures. Question number 2, a gas occupies 500 cc, cc means centimeter cube, under a pressure of 600 millimeter of mercury. Find under what pressure the gas will be reduced by 40% of its original volume, the temperature remaining constant throughout. Question number 3, what will be the volume of a gas when 3 liters of it is cooled down from 27 degrees Celsius to minus 73 degrees Celsius at constant pressure? So here you have two numericals. Now you have to identify which law is valid in these numericals and start solving them. Okay, so this much for today, boys. Stay safe and do all things well.